Now if we turn this experiment around the other way, and we have a 10-gram magnet on a little pole, and we're going to lift it up with the Dremel rather than push it down, you can see there's a certain balanced weight on the pole. It's holding it up in the air. I want to take the Dremel further and further away so there's no support. It drops down to the ground, has exactly the same weight. Now what's happening here, the weight of a top is the same whether it's elevated and spinning or dead weight. So this is the dead weight, and that's an upside down top that's just spinning. So of course they have the same gravity. On the other hand, suppose we now flip the poles of that magnet so that it attracts the Dremel rather than repelling it. We lift it up, and now you can see the Dremel's lifting it up by about 10 grams. And that's just magnetic dipole attraction, nothing to do with the top. So as we go away, the weight returns to normal. And when we flip the poles of that magnet one more time so that it repels the Dremel magnet, we lift it up here, it's only being held by top-like attraction. Now you see it has a certain weight. As it falls, the weight doesn't change. We can also do that with a 20-gram magnet, which is repulsive to the Dremel. Lift it up, hold it there by spin, and the weight doesn't change from at rest because it's just the physics of a spinning top. No change of gravity for a top-like motion, whether it's flat or raised or lowered. Then as we take it away slowly, it drops and the weight doesn't change. Now we can also do that with a 30-gram magnet, but we need to move the Dremel as far away from the magnet as possible to avoid magnetic dipole attractions. So let's put it up here and get it spinning. You see it's being attracted at short range. And as we move the Dremel further away, the top's getting higher. And you can see by the time you get up here with no magnetic dipole, the scale is balanced again. So it's holding it up with no change of gravity weight as long as you get rid of the magnetic dipoles. And when it falls, it remains balanced. Now we have a very long horizontal magnet, red north, blue south, with 5 magnets in a row. We'll start spinning it above the 30-gram magnet. You can see it's attracted, and then as we move it further away, the weight on the scale doesn't change. Also do that with a spinning cube magnet on the Dremel rather than a long horizontal magnet. Start it spinning, hold up your 60-gram of magnets, and you can see close range they're being attracted, the two objects. And if we move it further away to get rid of magnetic dipoles, you can see the weight on the scale, even 100 millimeters away, remains the same because the gravity of a spinning top is not affected by how high or low it is. We're up about 150 millimeters away, still hanging in there. There are no magnetic dipoles. The scale is perfectly balanced. 200 millimeter, it drops, and the weight doesn't change.